Hello everyone and welcome to day 19 of our object-oriented programming course. Today we will be diving into abstraction in OOP in Python. Let's explore what abstraction is, why it's important and how we can implement it in Python. First, let's define abstraction. Abstraction is the concept of hiding the complex implementation details of a system and exposing only the essential features. For example, when you use a smartphone, you interact with apps and features, but you don't need to understand how the hardware or software works internally. This simplifies the user experience and focuses only on what's necessary. Abstraction is incredibly important in software development. It simplifies complex systems by focusing only on relevant details. It also promotes modularity and reusability, allowing you to update one part of the system without affecting others. Additionally, abstraction enhances security by hiding sensitive implementation details, making your code more secure and maintainable. Now let's talk about abstract classes. An abstract class is a blueprint for other classes. It cannot be instantiated directly. Instead, it contains abstract methods that are declared but not implemented. These methods must be implemented by any subclass that inherits from the abstract class. However, an abstract class can also have concrete methods which are fully implemented. In Python, we use the ABC module to define abstract classes. The ABC class is the base for all abstract classes, and we use the @abstract method decorator to mark methods as abstract. This ensures that any subclass will provide its own implementation of these methods. An abstract method is a method declared in an abstract class but without an implementation. The purpose of abstract methods is to define a contract that any subclass must follow. This ensures that all subclasses provide their own specific behavior for these methods. Let's compare abstract classes with interfaces. In some programming languages, an interface is a strict contract that only allows abstract methods, while Python does not have a formal interface type. Abstract classes can serve the same purpose by defining only abstract methods. The key difference is that abstract classes can have both abstract and concrete methods, while interfaces typically only define methods to be implemented. So, what are the benefits of abstraction? First, it allows for code reusability. Abstract classes provide a common structure, so subclasses can reuse the logic. Abstraction also improves security as it hides implementation details from the user. Finally, it makes your code easier to maintain and extend, as changes in one part of the system do not affect others. Now let's put what we have learned into practice. For today's task, we will create an abstract class called vehicle. This class will have abstract methods like start engine and stop engine. We will then create subclasses such as car and bike and implement these methods in the respective subclasses. Here's a mini project idea, a library management system. We will create an abstract class called library item with methods like checkout and return item. Then we will create subclasses for specific items like book, DVD, and journal. This will help you understand how abstraction can be used to create a structured and scalable system. Let's quickly recap what we have learned. Abstraction helps us hide unnecessary details and focus on essential features. Abstract classes define a common interface for subclasses, ensuring consistency. Finally, abstraction promotes modularity, reusability, and security in our code. That's the end of our lesson on abstraction. Does anyone have any question or need further clarification on any points? Feel free to ask.